Okay, so let's do another alkene reaction, and we're going to set it up the exact same way as we did before with reacting our alkene with a hydrogen halide, and we're going to react that alkene with HBr. Just from the get-go, let's pause the video, try to predict the products that we're going to get from this reaction, and then after you draw out the products, try to predict which will be major, which will be minor. The three possible outcomes is that we can have a major, we can have a minor, or we could have an even split between the two. So go ahead and pause the video and try to do the next part. So now that you've unpaused the video and you have some products, it's probably not too big of a surprise the way that I phrased that last part, that there's going to be something a little weird going on for this example. And so this is one potential product that we could have for this reaction. And if we numbered the starting material, so 1, 2, 3, 4, 5, we're going to have 5 carbons to start. And if we put the bromine in this position, we would have added the bromine to position number 2 from the original alkene. And so if we have one scenario where the bromine could add to carbon 2, then if we look at the other carbon that used to be part of the alkene, that's going to be carbon 3. So that means that not only can carbon 2 be a potential holder of the bromine, but carbon 3 could also be a potential location for that bromine. So what I'm going to do is copy paste and copy paste. And so I'm just going to change that bromine position from being at carbon 2 to being at carbon 3. So that's the other possibility. And so after you drew these two products, when you did this on your own, you probably tried to go through rationalizing major and minor, like we did in the previous example, by considering carbocation intermediates, and that's definitely the way to go. If you don't think about carbocation intermediates, then it's going to be very difficult to rationalize which should be major, which should be minor, and if there is even any preference for major and minor. And so what you probably saw was, if you went through the mechanism, or at least if you predicted the intermediate products, then you would get something like these. And I'm just going to take the bromines off. So I'll get rid of this guy right here. Get rid of this bromine. Get rid of that bromine. And if you thought about the intermediates, and again, you have to think about the carbocations here, you'd get either a carbocation on carbon 2, or you'd get a carbocation on carbon 3. And in this case, we said we could predict major minor by thinking about the more stable carbocation. And in this case, if you think about this material on the left versus this intermediate material on the right, there's really no difference. There's no difference in carbocation stability here. We have a secondary carbocation and secondary carbocation. And although the structures are slightly different, at the end of the day, they're both secondary carbocations. And so since our only distinguishing criteria at this moment is primary versus secondary versus tertiary versus like maybe a methyl, that's really our only metric for being able to say whether a carbocation is more or less stable than another. And so in this case, since they're both secondary, there's really no preference by the molecule one way or the other. So really, if we went through the whole mechanism to get these potential product or these potential intermediates, we would have this kind of an arrow push where you'd have the alkene again abstracting a hydrogen from the HBr, and so this is our acid-base reaction, so we're making a bond and breaking a bond, and it's actually really important to make sure that that bond is right there, and we're starting our arrow from in between the two atoms, just like we're starting the arrow in between these two atoms. So we're showing the location for the origin of the electrons here within the bond, and also here within the bond. So that part's really important. So if we did those electron pushes with these two arrows, we could potentially draw either of these two products. And so since either of these two, intermediates, since both of these intermediates are equally stable, they'll be formed with equal, ratios or equal proportions. These will also be in a 50-50 mix. So the answer for this particular problem was that there was no major and minor products, and we would just get both of these products in a 50-50 ratio. So now if you wanted to practice your arrow pushing skills, let's try to show how you would get from these intermediates right here to these products right here. So go ahead and pause the video, see if you can do that. So now if you were to go from intermediate to product, we have to do a bond making process. So we have a negatively charged bromine, and we can just show the electrons attacking this positive charge. And so since that positive is obviously on carbon 2, you could have either drawn these electrons attacking the positive charge, and in that case it's obvious what carbon you're attacking, or if you really wanted to be rigorous, you could have this negative charge attacking that carbon 2 itself. Really, either way is the same, 6 of one, half a dozen of the other. So it doesn't really matter too much. You could do either one, and it would be obvious to whoever's reading this, you know what you're doing. So yeah, that's this problem right here. And so again, this is an example where we still get two different products. These are definitely two obviously different products, but they just happen to be a 50-50 mix and not a major minor.